So, again, this unit is about transformations. The first transformation we're going to talk about is translations. Some important vocab before we dive into it. Transformations are an important concept in geometry. Basically, a transformation takes an original shape, image, figure, etc. It creates a new figure from the original through slides, which is translation, which we're going to talk about today. Flips, which is a reflection, which we're also going to talk about today. Turns, which is a rotation, or enlargement/reductions, which are called dilations. Applications are often seen in artwork, tessellations. There's a really old book we don't really use anymore, but these can't be counted. We don't have that. So the translations. First transformation we're going to talk about is a geometric change in position. So it doesn't change the size or the shape. It literally takes one object and slides it over to another part of your grid. That's all you're doing, you're just sliding. The original figure, so the image you start with is called the pre-image. Whenever you're starting it, whatever figure or shape you start with, we call the pre-image. And that figure, after you do your transformation, is called the image. So we look at this diagram. We know this guy right here is the pre-image. Okay? I know this is the pre-image because there's no tick marks. It's just A, B, C. There's no little apostrophes or tick marks with those letters. Okay? We did some sort of transformation to get this new triangle, A, B, C, but I know this is my final image because there's tick marks. I know they might be hard to see, but there's little tick marks with the A, the B, and the C. And it's also a dotted line that helps indicate it too. When we draw ours, though, it'll be solid. Okay? So we know this is the pre-image. This is the image we started with. We did a transformation, and we ended up with this guy, and we know this is our final result because there's tick marks with it. The transformation we did is we moved each point left 5, 1, 2, 3, 4, 5, and up 2. We did the same thing with B. We moved it over 5, and then up 2. And the same thing with C. We moved it over left 5 and up 2. Okay. We can write rules, or you're going to be given rules for different transformations. To write a rule for this one, okay? We know we went left 5 and up 2. If we went to the left, what sign do you think 5 is going to have? Negative. Left is going to be negative. Okay, so that's technically a negative 5. We went up 2, so that's going to be what? Positive. Good. The left and down are negative, right and up are going to be positive. So you write a rule for translations. There's kind of two ways you can do it. One way which you're going to see often is writing little equations. So you have your x, y, you draw an arrow, and then you write equations for what just happened. So if we went left 5, we're going to write it as x minus 5. Because the 5 is negative. We went up 2, we're going to say y plus 2. Right? Your horizontal movement, because it's going the direction of the x-axis, is always tied to the x value. The up and down movement, the vertical movement, is going along the y-axis, so that's going to always be tied to the y value. Questions over there? You can see it as a capital T, and then these kind of pointed brackets. Again, the negative 5 is first, because that's representing your horizontal shift, your x shift, and then the positive 2 goes second, because that's representing your up and down shift. Questions over that? You'll see both of them. We'll write another rule here in this lesson. Again, some more vocab. If the pre-image and image are congruent, up perfectly with the image. The transformation is called isometry. Or in other words, we would call it a rigid motion. They're kind of hand in hand. I like the term rigid motion a little bit better. So you can see isometry, think rigid motion, and vice versa. That just means the original figure that you moved did not change size or shape. You just moved it. Okay? So the starting image and the ending image are exactly the same. You didn't change the size or the shape. That's all those words mean. It's also called a congruence transformation. We'll talk about that later down the road. That's another phrase for it.
So a lot of you guys are going to like these because they are very simple. As long as you know the patterns and see what it is, it's very easy. No calculator needed. You just have to count. I know some of you that's strange, but others you do really well with it. So let's see, just like we've been doing here, we have graphically labeled the figure W, X, Z, Y, and apply each of the transformations. Okay. Well, first thing first, let's graph like we have been doing. W is 2 1, excuse me. That's a W. Next one is 7 3 is X. 7 3 is X. That's it, right? Yep. X. Z is at 5 -2. 5 -2. That's a Z. And then Y is at a 3 -2. Let's get rid of my Z on the other side. And then the other one is 3 -2. 3 -2. That's Y. And we connect our figure. We have that. There is our pre-image. That's the one we start with. Now, it tells us here, now there's two different moves going on here, two different transformations. And they're written in both different ways you'll see it, the two different rules. Well, let's look at rule number 1 here. That's how you see it. You'll see a capitalized letter. The capitalized letter tells you what transformation to do. This one says with a T, so that means we're going to do a translation. That's the sliding one. So it's going to tell us where to slide. Here's they read this. It's got a 2, or it's got a T, capitalized T, then a 1 and a -3, and these letters. So what it's telling you is we're taking W, X, Z, Y, and we're moving in this direction. Again, X comes first, then Y. So it tells me that I'm going to move +1 in the X direction, then -3 in the Y direction. And that's going to move our shape. So I'm going to do that to every one of those points. So let's start with Y. I have to move +1, which will be to my right, and then I'm going to do -3, so that'll be down. So it looks like this. Over 1, down 3. 1, 2, 3. Here's Y. Put the little prime symbol right there beside it, that little tick mark. That shows you that it's going to be the image. So the original one was that the red Y up there. This new one is our image. So we're going to do that to every single one of those points. Z. To the right 1, down 3. 1, 2, 3. Here is Z prime. W. Over 1, down 3. Over 1, 1, 2, 3. W prime. And yes, it's sitting on the same point. That's fine. X. To the right 1, down 3. 1, 2, 3. X prime. And there it is. Now, if you notice, one thing we do recommend is if you have a highlighter, colored pencils, something to see this. Because a lot of times they will overlap. We'll do one later down the road where we're doing multiple movements. All right, so you can make sure. Well, if you notice, between the red one and the blue one, they're the exact same shape. All I did was I took the shape, I slid it to the right, down 3. Nothing changed other than that. Make sure you know that one. All right. Questions with that first transformation we did, the translation. Let's do the next one. This is the second way that you'll see it written as. And again, saying the same thing, just written a little differently. It's saying that we're moving the shape W, X, Z, Y, and we're moving it to these new coordinates. So every X coordinate, we move -5, and then the Y coordinate, we move +2. So we go left or right first. So I'm going to go left 5, then I'm going to go up 2. So let's try it. Go back to your pre-image, the red one we started with. So I'll do a W first. I'm going to go left 5, up 2. 1, 2, 3, 4, 5. 1, 2. Here's my W prime. These are two different moves, so. Let's go to y here. 1, 2, 3, 4, 5. 1, 2. Y prime. Z. 1, 2, 3, 4, 5. 1, 2. Z prime. And the same thing for my x. 1, 2, 3, 4, 5. 1, 2. X prime. And there's my figure. So notice the figures stayed exactly the same. It's just sliding to a new location. That's all it is. Get the same size and same shape. This one's in blue. Questions? If you can count, you can do this. Just make sure you go left or right first, then up or down. Good? All right, let's do the reverse of it. If we have the rule, we can graph it. What do we have a graph? How do you find the rule?
So we're going to go ahead and write a rule for this transformation. Which figure are we going to start with? Which one's our pre-image? Was the bottom one or the top one? How do we know it's the top one? Or tell us it's the top one. A little louder, Genesis? Yeah, it doesn't have little prime marks, but little tick marks. That you know is the image we're starting with. It's our pre-image. So we have to figure out how we took this figure and moved it over to match up with this one. Okay? We're going to write the rule both ways so you kind of get in the habit. We're going to do kind of an equation way first. Okay? Alright. So figure out, pick any point, A, B, C, or D, it doesn't matter. Which one do we want to pick? A. We're going to start with A. Then we have to figure out how we move A to match up with A prime. Okay? So do we move to the left or the right first? To the left. How far to the left did we go? 7, or 7, say 8. Good. So you're going to count. So you're right in line with A. And we went to the left 8. What kind of sign are we going to put in front of that 8? Negative. Left 8. You're going to count to your line with that other point. And then count again till you're touching it. How far did we count? 7. And we went down -7. Right? So that's saying we went left 8 and down 7. Right? When we write that as a rule, one of the ways is the equation way. We have x and y. All you do is just do -8. So the x minus 8. And the other one would be y minus 7. You just count over and down or over and up. X is always first, so we have -8, so it's going to be x minus 8. And then our up and down go second, so we do y minus 7. So that's one way of writing a rule. Another way that you'll see it, you might be able to write it, is you just do a capital T. Put your little brackets. Again, your x movement goes first, so we're going to write -8. And then your y movement goes second, so -7. And then you just write the letters of the shape you move, A, B, C, D. Either way is a correct way to write a rule. You might be asked to write it the equation way. But it's coming up sometime soon, so keep that in mind. Questions over that? Okay. Was this an isometry, or in other words, a rigid motion? Did anything change? Did the size or shape change? No. So is this an isometry? Yes. If the size or shape did not change, then you know it's a rigid motion. You know it's an isometry. Okay? True or false, any translation is a rigid motion or an isometry. Yes?
Just a quick question. E would be -8, -7. A through D. That's important, right? That's important that we memorize that.
Yeah.
the format of it. It's going to change, your numbers will change, and what you're moving is going to change, but the capital T doesn't mean translation. Yep.
Whenever you see a capital T, that's the translation you're going to do. So just count over and up and down. But true or false, any translation is a rigid motion? Take it. All the examples we just did of translations, all these different translations we did, does the size or shape of the figure ever change? No. So Seth, what do we think it is? True.
You're just sliding something around. Think of like anything. You're sliding around on your desk. Is it going to change shape or size? No.
Nope. You're just changing its location. You're not changing how big or small it is.
Good. Counting. Not too bad, right? Well, let's go to the next one. Reflection. Good one. Well, you guys hopefully know what a reflection is. Most of you probably looked in the mirror this morning and said, hey, what's up? So, you know what's going on here. A reflection is a type of transformation in which a geometric figure is flipped over a line of reflection. It's flipped over a line of reflection. So, something is being flipped over here. Now, there's one thing about this. It's kind of like the same thing when you're looking at a mirror. Some of you know this, some of you don't. If you look at a mirror, obviously you see yourself, but the image is what? It's reversed. It's backwards. It's the same thing here with this. In reflection, the pre-image and the image have opposite orientations, but are the same shape and size. What's that mean? I like to think of this. If you think of an arrow that's pointing to the left, and you flip it over an axis, it's now going to be pointing to the right. All right? So it just changes the way it faces. So keep that in mind. So if they're facing the same way, it was obviously not a reflection. All right. So it brings the question, true or false? A reflection is a rigid motion. Does it change shape or size when I flip it? Oh, so true. It is a rigid motion. It does not change shape or size. I can flip it all I want. It's not getting bigger or smaller. So how do we go about doing this? Well, again, this is real easy. It's just counting. No calculations needed for this one. To graph reflection image on a quarter plane, graph the image of each vertex. Each vertex in the image must be the same distance from the line of reflection as the corresponding vertex in the pre-image. All right. Below are a few guidelines, however, sometimes it's best to simply graph the figure. There are rules. There's little things you need to do. So this one right here is talking about reflecting across the x-axis. If I want to flip something to the x-axis, what do? Well, here's what the rule looks like. The capital R stands for reflection. There's another one coming up that is not a capital R. Tells me what to flip it over, x-axis, and then the point that I'm flipping would be point A. So the rule is basically this. Whatever the points are, you just change the y. So if the y was a negative, now it becomes a positive. And vice versa. If it was positive, it becomes negative. So that's what it is. Flipping across the x, you flip the y. Kind of opposite one another. Same thing goes to the other side. If I'm flipping across the y-axis, I need to change the x sign. But you'll see that it's much easier if you just graph it and count. And we'll see what we're talking about here in a second. So let's give it a go. So we've got a figure in this triangle ABC. And we're going to graph those points and we're going to reflect it across the x-axis. So a couple things going on here. But first, let's graph. A, 2, 4. B, 6, 5. C is at 3, 1. And there's your little image, or pre-image, excuse me. All right, we're going to reflect it across the x-axis. It helps to know where that x-axis is at. So I like to highlight it. Another thing to have a highlighter, I definitely have it for this. Where you got a different color pencil or pen, just so you can easily see it, so it's not just all pencil on your paper. X-axis is right here. I'm flipping it across that. Now here's how easy it is. You count. Bruce, good. You count? Good job. So, we're going to try it out. We'll use the test. Sam, point C. How far away is C from that purple line? 1. Good. You can't count. You proved yourself right. It's good. It's 1. Well, not only do I go 1 here, I want to go across the line. So guess how far I go on the other side? 1. That's it. So just basically count and say, all right, it's 1. So I go 1 the other way, There's my new image, C prime. Let's say with the other points too. Let's do A. How far away is A from that line? Perfect. So I have to go 4 the other way. 1, 2, 3, 4. There's A prime. The last one's B that we haven't done. How far? 5. Go down 5. 1, 2, 3, 4, 5. B prime. Connect up your dots. And there is your image. Yes? You could do the opposite. Depends what it is. It does work, yes. Some people are very oriented with the numbers, and they're saying, hey, I like working with numbers better than counting, which is fine. So you have your original points. We said we're flipping it across the x-axis, so all you have to do to get these points, is change the y's. So all the x's remain the same, but we just changed the y. So it was a positive 4, now it becomes a negative 4. It was a positive 5, becomes a negative 5. It was a positive 1, becomes a negative 1. Yeah, you can graph it that way. If you know it's flipped across the x, just change those. Graph it. You can do that. Some people like do it that way. They just say, all right, if it's going across the x, I change the y's. If it's going across the y, I change the x's. I find that you just graph it and say, all right, I'm flipping over that. Just count. However you want to do it. Good things. And notice the images are flipped. It's kind of like a mirrored image, like a butterfly shutting its wings. Or back in the day when you guys made the snowflakes in kindergarten or whatever, where you pull the paper up and cut it all out and open it up. It's kind of a mirrored image. That's exactly what's happening here. It's symmetry. All right. Good on that? All right, let's try some other examples.
This next set of examples, go ahead and on first grid, graph your free image, which is this triangle of -3, 4, 0, 1, and 4, 2. Okay. We want to reflect this triangle over the line x equals 2. We'll draw that line. We're going to go to where x is -2. And you're going to draw the line like so. It's super tempting to go across, but the line that we want to graph is x equals -2. So we only want the x value on that line to be -2. If you go across, you're saying that x is -10, x is -4, x is 2, x is 6, you go across. So whenever it's x, you're just going up and down like so. Okay? And then you follow the same rules. I know the line you're reflecting over is like inside that triangle. That's okay. The rules still apply. You just take each point and count how far it is from the line. So if we look at A, how far is A from that green line? 1. So then you go to the green line and you count 1 away. And there's your A prime. Okay. Do the same thing with B. How far is B from that green line? 2. So you count 1, 2 to the green line and you just go 1, 2. And then how far, if we count, C is how far from the green line? 6. So you count 1, 2, 3, 4, 5, 6 to the green line, and then you go 1, 2, 3, 4, 5, 6 away from the green line. There you go. And then you just connect the line.
Straight edges would be nice here too. Look nice and pretty for you guys.
Questions over that? Okay. These next two examples are a little different. We're still going to plot this pre-image the same way we did. We have A, B, and C. But this time we're going to reflect it over the line y equals x. So this is probably the very first line you ever graphed in algebra. When you graph the line y equals x, you just start at the origin. Just count up and over. Up 1, over 1. There's no line intercept, so you start this at the origin. There's just an X, so that means there's just a 1 in front of the X. You just count up 1, right 1. So we went up 1, right 1. What other direction can we go?
Down one, left one.
Down 1 left. We'll just go in the opposite direction.
Where did we circle?
Origin.
Nothing's been added or subtracted, so we just start right in the middle. Okay? And we want to reflect it over that line. Okay? I know it's a little different, but you're still, all you're doing is counting. You're just counting in a slightly different way. So we're going to start with C. We'll start with A. Go over. So when we reflect A, I want to just go up and down first. So we want to go count so A touches that line. Well, in order for A to touch that line, are we going to count up or are we going to count down? Okay, so we're going to count down. How far do we count down? 7. So count it down 7. Now what you want to do, you're not just going to go 1, 2, 3, 4, 5, 6, 7. That's not going to work out. Okay? You're going, it's like you're making a little right angle. Okay, so we went down 7. We're then going to go right 7. Okay, and that's your A prime. Here's the thing. You don't, if you go down, you're going to go horizontally. You want to make sure that the line is in between these 2 points. So how the line is in between A and A prime? If you went left, 1, 2, 3, 4, 5, 6, 7, that line is not in between these 2 points. They're on the same side of the line. We don't want that. We want them on opposite sides of the line. So that line's like going right in the middle of those 2 points. So that kind of helps you decide which, if you're going left or right. Okay? Do the same thing with B. Right? We count. So B touches the line. Are we going to count up or are we going to count down? In order for B to touch that line. Down. How far do we count down? 1. So are we going to go left 1 or right 1? Yeah, right 1. Because we want that diagonal line to be in between our 2 points. Okay? So that's a good indicator of which direction you're going to go. And then for C to touch that line, are we going to count up or down? Up. How far do we count up? Are we going to go right 2 or left 2? Yep. Okay? Because again, we want that line to be in between our 2 points. If we went right 2, these are on the same side, the line's not in between them. So that doesn't work. And once you do that with all 3 points, you just connect. Yep. So all you're doing is counting, you're just kind of changing directions when you count. Right? Same thing applies with C. Again, draw that image, ABC. Graph that right. It was 4, 2. 1, 2, 4. And this time you're going to graph the line y equals negative x. It's literally the same exact line, it just has a negative slope. So you're still going to start at the origin. But instead of going up 1, right 1, you just go up 1, left 1. So it's the same exact line, it's just pointing the other direction. If we want up 1, left 1, go the opposite direction, down 1, right 1. And those same rules still apply. We're still counting, you're just changing directions when you count. So we start with A, Are we going to count up or down so that A touches that diagonal line? Down. How far do we count down? 1. Are we going to go to the right one or to the left one? Because again, we want them on opposite sides of that line. The line's in between those 2 points. If you end up the line not being in between those points, you went the wrong direction. Okay? We go to B, are we going to count up or down to touch that line? Count up, or are we going to count down? Down, how far are we going to count down? 1. Are we going to go right one, or are we going to go left one? Left. And then for C, are we going to count up or down? Down. We went down 6, are we going to go right 6 or left 6? And we want this to be in between our 2 lines. Like so. And then you just connect. This is probably the trickier of the reflections. You'll get more practice with this on Thursday, so it's not on your quiz. Give you more time to kind of work on that. But just tomorrow, it's just translations on your quiz.